Warm welcome to everyone. Moving on to the session 2 of day 1. Topic of this session is Smart Grid Operation and Control, Issues, Challenges and Opportunities. And we have Professor Dr. D N Gaonkar, sir, as a speaker for this session. I am happy to introduce today's eminent speaker. He is presently working as Associate Professor, National Institute of Technology, Karnataka, Surathkal. Sir received his B.Tech degree in Electrical and Electronics from BVB College of Engineering and Technology, Hubli in the year 1998. M.Tech degree in Power and Energy Systems from National Institute of Technology, Karnataka in the year 2003, and his PhD degree in Power Systems in the year 2008 from the Indian Institute of Technology, IIT Roorkee, India. He was a visiting scholar at the University of Saskatchewan, Canada. He also visited Center for Further Energy Systems at Rensselaer Polytechnic Institute, Troy, New York, and Energy Reliability and Security Laboratory at Michigan State University at East Lansing, USA, and Energy Management and Microgrid Laboratory at NUS Singapore for research interactions. He also participated in the international conferences held in USA, Denmark, Egypt, Malaysia. He has edited and written a chapter in the book titled Distributed Generation, which is published by Intech Publication, Austria. He was the member of the Task Force Committee on the Distribution and Distributed Generation under National Perspective Plan of Ministry of Power Government of India. He has guided 8 PhD students and 5 more are ongoing. He has completed 3 research projects in the research area of microgrid and photovoltaic systems. He has published 42 research papers in reputed journals and 60 papers in conferences so far. He has delivered 35 invited lectures on the issues related to distributed generation and smart grid. He has 2 Best Paper awards to his credit. He is the senior member of IEEE and fellow of IE India, life member of ISTE and SSI. He was also the ExCom member of the IEEE PES Bangalore chapter for the year 2014 and 15. His main research interests are in the area of power system operation and control, distributed generation system, and power electronics. We are happy to have you with us, sir. Now I request sir to please start the session.
Okay. Thank you and good afternoon to everybody. Thank you for the team organizing this workshop. It's a nice to be through online platform there. Of course, you might have had a wonderful the inaugural function, and this might be the first talk in your this workshop. Of course, as I was going through the title, as it says, it's mainly IoT and the advance in power electronics in what you call the smart grid, for the smart grid application. As you know, this is a very important thing, that both are very much a part of what you call the smart grid which we are talking about. Okay, so hope I will take you through what you call the entire the smart grid issues, the challenges, and the technology available. Of course, I will share my own experience, what we have done in the as a research in our institute. Of course, this is what you call things where you can learn, really see the issues in a smart grid, and also you can think of what you call can do a lot of research. You can take some of those things and do your research. Okay, so of course we'll have a question at the what you call the later part of the session. Okay, so initially we'll go through the what you call the various topics. This is what I will do. Of course, before I go to what you call the exact the issues of a smart grid, let us know what is exactly our grid at the right moment. Okay, so because this will what you call give you a lot of things about the smart grid, how it got evolved. Okay, of course, and what is the current status of our grid. As you know, hope you might all know that the total generation capacity at this moment, okay, is around 370 gigawatts. Okay, think of the people says that we have a surplus energy. Okay, surplus, that means we are capable, we have the required amount of the supply. Okay, of course, there are a lot of problem, we are not able to reach all. Okay, so from this what you call very less capacity of a generation, we have grown up to what you call 370 gigawatts of generation. Of course, this data you can see even in the website of the new and renewable energy ministry website. And if you somebody asked you what exactly changed our the Indian power sector, okay, so we witnessing a lot of changes in our sector. Okay, the power this one. If somebody asks you, then the first thing which has changed our what you call the power this thing is the one is the increase, tremendous increase in the generation capacity. Of course, the act, the Electricity Act, which came into existence from 2003 onwards, was also is also responsible for changing our entire power system, because that brought what you call the private players in generation, transmission, and distribution. Of course, we implemented a lot of things about deregulation things. Okay, like what you call making several companies. Now every state has three companies, in the sense generation, transmission, and distribution. Among distribution, we have several companies. Of course, there are people are coming up in generation, but not much at the distribution and the transmission level. Still, it has to be privatized. Okay, so there is a lot of competition is happening. That is the one thing which what you call led to the present era of smart grid. If that kind of things were not enabled, then our smart grid might dream might not be coming into picture. Okay, so that is another thing. And another one more thing is the our what you call intention to use the sustainable technology is growing. That is, the people are thinking to utilize more of sustainable energy, what you call the generation, rather than the generation based on the fossil fuel plants. Okay, like the coal, the dependency on the coal, the gas, and the other kind of the fossil fuel based plants are getting what you call is the interest is going down, and now the interest is started utilizing what you call the more of renewable energy sources. If you talk about in that category, we have a large these things with respect to wind and the solar. Okay, of course, the future next 20 years we'll see a lot of wind and solar integration. There are many other things, but all are might not be of that kind of the scale. Okay, and as you know, India is the third largest producer of the electrical this thing electricity, and also we have a surplus. But problem is, even if you have a surplus, but there is a lack of a distribution infrastructure that made us to not to that made us that we are not reaching the all. Okay, so if you talk about the total overall generation capacity, okay, of 370 gigawatts, in that what we can think of, around 34% of come from the renewable sources. Of course, when I say 34, it includes the hydro. If you talk only of the renewable, excluding the idle plants which are there since the beginning of the power system. Okay, so only the renewable has come into picture now. Okay, so if you exclude the idle power plants, you will get the contribution or the penetration level is around 18 to 20%. We can talk about 20% as we are growing. Okay, of course, this is compared to many countries, the developed countries in the world. This what you call is low. Okay, we need to move on. Okay, so we are maybe fourth or fifth largest in introducing the wind and kind of a solar power plants into grid. Okay, so you can see the installed capacity. You can talk about, you can think about the renewable sources. This is around what you call, this is at July 30th. Of course, this might have changed. You can think of the penetration level is 20% in case of the current grid. Okay, apart from still we have what you call the major things are coming. What you call from the other kind of plants. Okay, so there may be what you call the renewables or that kind of things are growing. As of course, the integration of the renewable is going, and the consumption pattern also, you see that the last, I think we are all undergoing the COVID situation. Okay, so you might be seeing both industry as well as residential sectors are now up, because you know most of our activities move to the home. Even industrial activities, especially the software industry and other things, they move to the home. So home the loads are increasing, and you know online platform, we do a lot of the teaching activity through online and other things. Most of the schools and other things are now operating through the home based kind of environment. Okay, so what is happening is we do see this might be only for the last 6 months. Okay, of course, we have a share with respect to industry and the residential, the agricultural sector, all the, there is a consumption. Okay, so if you talk about the private sector, present private sector participation is 46%. This has to go up. Okay, and losses. Another important thing in case of our power system is the losses. Okay, the power system, the losses in India is around 20%. We are in the dream to reduce it to very low, below 10%. Of course, it is maybe a long journey. Okay, of course, we are talking about around 14 to 15% reduction to that level. Okay, of course, a world best average is around 4 to 8% in Japanese network. Okay, so that's what we need to move on into what you call reducing the T&D loss, reducing our dependency on the fossil, and increasing the renewable. Right now, 18 to higher, around 50%. Okay, and then what you call the decrease in the fossil should happen. Okay, so before going to a smart grid, it is very important to understand how present power system is operating. Okay, if you have the clear picture of the present power system, how things are happening, what is the interest in this power system, what is that you need to control so that the power system is safe, secure, and reliable. Okay, so that's what we look into. Okay, so as you know, the important component of our power system is the one side we have a generation. We transmit power, whatever generated, rise the voltage level. Some of you might be knowing that why you do so, and then transmit, and then we send the what you call the power to distribution centers, substations, and other things. From there again, the voltage you will step down the voltage and supply it to the customers. Okay, so consumers or the customers. Now we talk about the customers. Okay, so there are different kind of customers: industrial customers, what you call the agricultural, then the residential. The different kind of customers are also there. Okay, so their nature, the loading pattern, all may be different. It all depends upon their requirement. Okay, apart from that, we have what you call the control equipment also in the power system. A lot of control equipment. in the transmission distribution system. If you go to even on the generation control systems are very old, these things, in the sense from this inception of a generation station, we'll have a lot of big control room in the generating station. Those who might have visited a generation plant, you might be knowing the importance of the control room. Okay, and then what you call even in the transmission sector and the substation, okay, we have a lot of control equipments, okay, and what you call the protective equipments. Okay, so these are all becomes a part of our power system. Of course, when I say power system, we all talk about the huge interconnected network. Okay, so that itself is not only the system. Okay, there are many other kind of system also exist. Okay, so we might not have what you call heard, or we might not have given a concentration on those kind of plants. Of course, as you know, there is a power system called air. In these airplanes and spaceship, they require their own what you call power characteristics. Okay, so power system maybe depends, can be classified based on the requirement of the power supply. Okay, so it may be the supply exists in airplanes and spaceship, which may work at 400 volts, whereas our conventional interconnected, what you see day to day in our life, is generally supply voltage at 230 volt and the frequency at 50 hertz. Okay, of course 230, it all depends, maybe residential customer, for industry and other thing 415 volt. Okay, so some maybe at a different voltage level, even 11 kV also we are now talking about as a what you call the distribution level voltage. Okay, so apart from that, but in other kind of a system like in airplanes and other things, they require a different characteristic supply, what you call 400 hertz. In ships, submarines, we have a different things. And another important things, and next, as you know, the important things which may come up on our grid is the automobile sector, the transportation sector. Transportation sector works on what you call the battery current right now. Okay, so this battery is it's maybe a 12 volt battery system. Okay, so this kind of things becomes what you call the battery based system. Of course, there are different kind of technologies also there. They have their own characteristics. We do use maybe a DC motor. Okay, so people are also talking about induction motors also for vehicle application. Apart from that, we do know in any house we have a different kind of a systems, like we have a mobile which may be working around 3 to 5 volt or maybe less than that. Okay, so and also other gadgets. Okay, so people are also talking about the complete home with the DC supply. Okay, so there are different kind of power system. So if somebody asks what exactly the different systems, they classified based on the characteristics of the supply. Okay, so you may have a different kind of power system. Okay, so and also another important thing is we have in an interconnected network, interconnection is happening at local grid level, the state level, and then national level. Okay, remember India has now the complete interconnected national grid, which was not there earlier. Okay, all states are connected. We can now export power from one state to another state easily. Okay, so there is what you call the national grid exists. Okay, and as you know, these are all highly interconnected network. The power system is one of the very highly complicated as well as interconnected network. Okay, so we have what you call large intersection. Even if you can see from the each substation, there will be several feeders, several substations are getting connected. So many things. So these are all what you call highly, the current power system is highly interconnected. Okay, and also we can transport, we can supply from one region to one state to another state. Of course, we do not have interconnect in the international level. Okay, whereas that is there in some of the European countries. They have the interconnected international what you call the grid. Okay, so that is the kind of things which may which is the current scenario in a power system. Of course, if you talk about what is the difficulty in what you call operating this system, okay, what that people are trying to do to operate this system in a reliable, secured way is, as you know, all of our loads are designed to operate at a particular voltage and the frequency. If you are not able to maintain this voltage and the frequency, okay, so then the system what you call the system will go into what you call the stage where the operation become difficult. Okay, so maintaining the voltage and the frequency becomes a very important criteria in the power system operation. The goal of what is the goal of power system operation is the operate the power system with a constant voltage and the frequency. If you are not able to maintain this, the power supply will be shut down to that particular substation or feeder or that particular part of the network. Okay, so if goal is to control voltage and the frequency, okay, of course the minimum cost comes into picture, safety, reliability, that is the next part of it. And another things why that is so much difficult is, as you know, in a power system, from morning to evening the load keep on changing and it is not in the operator control. Okay, load is the customer control and he operates based on his own requirement. Each individual customer will have its own requirement. Okay, so the operator has to control the voltage and frequency in such a way that the control the generation, the supply and demand in such a way that the voltage and the frequency what you call are going to be within the statutory limit. Okay, so supplying the matching the demand and supply becomes a very important things in voltage and the frequency control. Okay, as long as if you are able to match supply and demand, which is very difficult, and the nature of variation is not possible to predict. Of course, we do have a lot of stochastic methods and other things, but we may not able to completely predict it. Okay, because loads operate based on the customer requirements. Okay, so generation we know we have a control, but at the load side we do not have. Okay, so you have to see that always load and supply are the matched. Okay, as long as if you are able to match, this issue won't take place. That is violation of voltage and the frequency limit. Okay, so major important goal of any kind of power system operation is to control voltage and the frequency. Okay, if whether it's a smart grid or any kind of a things, as long as you are able to match demand and supply, you are able to maintain the voltage and the frequency. Okay, why so it's complex? Some of you know already, might have studied why it is difficult to match supply and demand and later keep the voltage and the frequency within the tolerance limit. It's all because there is a lot of complexity. As you know, our network is a unidirectional, in the sense our network has been built that we generate power at one end and keep distributing on the other end, and nobody allowed to connect any kind of generation source on the distribution side. Okay, that means only we have a central generation and nowhere else generators were not allowed to what you call the connect. Okay, so that is the kind of what you call the passive the structure. Okay, but as you know, now things are changing where we see lot of generation sources are coming on the distribution. What will happen? Okay, is the network becomes bidirectional. So passive network will become an active. Okay, so that is a kind of a complexity. We have not built up our network through what you call the take care this effect. Take care the effect introduced or situation comes out of the bidirectional power flow. And network is very complex. Okay, it's very complicated to control, and as you know, balancing a generation and demand is one of the important things where it's very difficult to do that. And because one side the load will keep varying, and another side in the future also it will become further complicated because of the renewable sources. Lack of flexibility in the network, that we are not able to what you call the provide a flexibility to the customer to what you call supply, flexibility of supply and other things. Okay, the network flexibility. Okay, and also there is no ideal source exist, and the loads seldom will the loads never be constant, it will keep varying. You can see from night to morning to afternoon to evening, it will keep varying. Okay, so it all depends upon the customer, industry, operation, all those things. And another important thing is our power system is highly non-linear. We are very much what you call the compatible when things are linear. When things becomes non-linear, that's where the problem starts. And our network is highly non-linear. It is of you might have studied a lot of things, courses in which you studied about the knowing inductance, capacitance, and network parameters and other things. You might have done this course. Okay, so there are a lot of issues which makes our network completely non-linear, and of course the redundancy is one of the important what you call things which is required, but there is no redundancy. If something happens on one part, very difficult to get supply to that kind of a customer. Okay, and also the network, if there is a problem, then we may not have alternative path for supply to him. Okay, and another important things what I talked about is the loss in our system. That is, we are quoting a figure of 20% T&D loss. Out of the 20% of wastage of power is happening, okay, which does not accounted in any utilization. That is, it's completely waste. Okay, so why can't we make our network more efficient, reduce the loss to a what you call possible figure of 12 to 14%? Of course, world average, as I told you just now earlier, that world average is around 4 to 8% the operational the T&D loss. Okay, so it takes into entire loss of the system. Okay, so transmission and distribution loss is another things which is making inefficient. Not only this, there are several other things makes network, the present network, inefficient. Okay, the stability issue is there, and another things, because now, as you know, we are all going on a big implementation of the things, making a conversion into online mode. Okay, so when you talk about online mode, always there is a vulnerable to this kind of things, to the what you call the cyber attacks. Okay, so there is a lot of things which make take your data and other things, create a problem. All these are the things which lead to what you call make the control of voltage and the frequency difficult, the complicated. Okay, then so once you know what is the power system, what are the things required to be controlled, why the power system is more complex, then we'll move into what exactly is smart grid. From a conventional grid to a smart grid era. If I ask somebody, okay, they simply may say that any smart grid is smart because it has an IT. IT is, it has an information technology. Okay, so where you can control through your computer system. Of course, that itself is not a smart grid. Okay, smart grid, in short, you can say that we can do a lot of information processing. Okay, we enable with our conventional grid with this IT. Okay, of course, itself is not the exactly smart grid. What exactly we want from our grid is, it if something happens on the grid must be able to rectify itself and what you call try and come back to its original and supply to the customer without the notice of the customer. Okay, so that is kind of a self-healing. If something problem, the network itself must be able to do its own healing. Okay, so that's what is called self-healing. And network, you should have what you call it information based and communicating, which are must comes with IT. Okay, and network is more secure, should be secure, reliable, we need to have 24/7. As you know, now everything activity is happening from home. Okay, even your the industry, the laptop morning, if you turn it on, and you may require to switch it only in the midnight, because you may do the both what you call your the household, every activity is coming what you call linked with the online platform. Okay, so that is the what you call the things. In these cases, we need to have a 24/7 supply. Industries are moving towards the home. Okay, so where their operation is becoming home, becoming the operational this thing. Okay, so it's you need to have a 24/7 power supply. You need to have the flexible network. You know what is meant by a flexibility. Okay, the flexibility becomes a very important factor. Okay, in any what you call the future solution. Okay, and then cost effective, and other thing is it should be a dynamically controllable. Okay, you need to have a real time control of your grid, a grid which gives all this what you call attributes, or grid which has all this attribute, you can call them as a smart grid. Okay, the smart grid becomes really smart when you have all these things. If you just have an IT, it may not. But of course, these things become much more complicated when you are what you call having renewable sources on the grid. Okay, so, and as you know, when you talk about the current or the grid, which where centralized generation is the important factor of important things of the same. Okay, where you have a dependency, we have what you call, you can depend on our generation. You put coal whatever amount and get whatever required, but that is not the truth. That is not the case in case of a renewable. Renewable, we do not have control over input. Only thing you need to control the output. And our grid is operate at a constant voltage and frequency. Controlling the renewable becomes a very important things. So if you talk about challenges which may come up in the smart grid, is controlling or the operation and control of the grid with renewables. Okay, and if you have a grid without renewables or without the distributed generation source, it may not be much difficult to control. That's what you can have IT can do a lot of things there. But problem comes with the integration of the renewable. Current, as you know, our government has a lot of the plan to go for larger penetration of the renewables, especially the solar and wind. You can imagine the right now it's 80%. We are not able to witness a lot of issues, but future will be more and more issues will come up because of the renewables. We do not have control over the input. Only you can do control the output. Okay, apart from renewables, as you know, we do not know when wind will pick up, when solar will comes up in a inject. Of course, the solar is more steady than the wind. Okay, so storage is one of the important factor. As you know, the future depends upon the your lithium-ion battery. As you know, most of our everywhere we are what you call thinking of utilizing the lithium-ion batteries as a supply. Okay, so storage is going to be a very challenging issue in the smart grid. Okay, and also the operation of a control of this kind of a smart grid becomes a very important things. Of course, remember what you may want is your grid as smart, and what I may expect as a smart feature of the grid. There may be a variation. Right now, if you talk about Indian context, we are interested in introducing more and more renewables and bring what you call some of the flexibility in network. Okay, and try to introduce the some IT things in the network. These are all things of our dream of a smart grid. Okay, so first thing what we are doing is integrating a lot of renewables into the grid, increase the penetration level, and so that our dependency on the fossil fuel becomes less. So increasing this becomes a very important challenge in case of the smart grid. I will talk about a lot of issues which we will see verify with a simulation result also. Before going to issue of how renewable are creating a lot of issues, we need to understand what are those kind of sources, how they can be connected to grid. Once you know that the type of topology and other things, then we look into how this will create an issue in the grid. Okay, what are those issues and other things? As you know, we all you might have already gone through some courses related to renewable sources. You know what are those renewable sources. I will not going to repeat of those technologies, their introduction and other things. You are all know the familiar with the wind turbine. Wind turbine and photovoltaic systems are going to become in a huge scale part of our network. Okay, so we may think of the implementation of wind turbine, grid connection of wind turbine and photovoltaic system in a large scale. Right now, as I told you, around 20% of Indian generation is coming from this kind of system. Of course, there are many other kind of things. They're all not in that kind of a scale. They're all maybe in a demonstration level or very low level. Okay, so future is belong to what you call the wind and photovoltaic system. Apart from renewable, you know, the current, the thermal power stations are generating power at an efficiency of, you all know this figure, that is around 24%. Some of the clean coal technology are quoting figure of 28 to 30% also. But you think of whatever you generate, a 30% power will get wasted. Okay, so that is, we are not able to reduce this. Of course, if you have a system which can generate power at very high efficiency, like a 60 to 70%. Okay, so that is the remarkable improvement in the efficiency. So there are a technology which can be called as an energy efficient technologies, like a micro turbine and fuel cell. You know, fuel cell has a lot of possibility to come on the smart grid network because it uses the hydrogen. Hydrogen is can be, you can get hydrogen from your water. Water is going to become an important source for an hydrogen in future. Okay, so that is where you don't have what you call do a lot of things about the hydrogen. You have availability of hydrogen. Why can't you generate power in a bigger scale? Right now they are very costlier. Okay, so right now they are very costlier compared to wind and photovoltaic system. Okay, apart from that, you know how to interface solar, the wind photovoltaic systems. Okay, and you know there are conventional things. You know the current power system is running with a synchronous generator. There is a large number of turbo alternators are utilized in generating power. Okay, from thermal power station, hydel power station, nuclear power station, we do use those things. They are conventional synchronous generator things. Of course, induction generator, we don't have much things, especially they are utilized in old wind systems. Okay, only in some cases in hydel power plants, they do utilize the induction generator. Of course, they have their own characteristics. The current trend and the current technology which is used to interface is power electronic things. That's what your the workshop title is. What is the advance in power electronics in interfacing the renewable sources to the smart grid? That is where your topic, I think you may much deal with power electronics later. Okay, so the power electronics becomes a very important efficient way to integrate renewable sources. Not only renewable, all kind of other kind of energy efficient source also. It has a lot of potential. Okay, so we have the fuel cell technology in our institute. We have 1.2 kilowatt heliocentric fuel cell. Okay, so you can see the fuel cell technology. Of course, we will see the interface. You see the hydrogen cylinder. Okay, so this is the technology which is going to come in a larger scale in future. Okay, so this is what we have in our institute. And then how do you, because before going to issue, how do you interface what you call your renewable source to grid? Okay, so conventionally we are using, as I told you, that the conventional generation system uses a synchronous generator. Synchronous generator has a large amount of inertia, and also it can feel what you call it is the problem. It has the characteristic of supplying large amount the fault current during if there is any fault. Okay, so but synchronous generator has a reactive power controllability, that you can control the voltage. Okay, but it has a large inertia. The flexibility of control is because of the inertia, it is not so fast as that of your power electronics. Okay, so power electronics technology are there based on switches. They are having no inertia. They come on grid and go out of the grid at very highly very faster rate. You can inject huge amount of power suddenly, okay, using a power electronic technology. They respond for such kind of variation, whereas a synchronous generator has a large amount of inertia. Okay, so they are not that kind of flexibility exists in faster control. Okay, of course the induction generator do not have the reactive power controllability. You require a bank of the capacitor or maybe statcom things to supply the reactive power. Okay, so from prime mover, okay, so once you generate power, okay, electric power, then convert into the mechanical power, then convert into electric power, and then make this electric power suitable to grid. As you know, our grid is operating at constant voltage and frequency. Whatever at the generator side may not be same. Okay, so you need to transform this power to that of the characteristics of the grid. Okay, so we require a power electronic interface. Of course, in case of the PV system, we do not have a prime mover as such. You have, this generator DC. It is require a power electronic interface to boost the DC to DC and then AC. Okay, so that is the thing, and that means, as you know, most of the renewable sources storage systems all require a power electronic interface. Power electronic has become an efficient interface, what you call for integrating the renewable sources. That's what we see. A lot of the importance has come up on the power electronics. Okay, and you can see any research paper on renewable. They talk about more of power electronics converter topologies for integrating various kind of the renewable energy and storage devices. Okay, so there are a lot of topologies have come up. Okay, so the passive rectifier inverter topologies and DC-DC converter, because wherever the generation source generate a DC like a photovoltaic and fuel cell system, we have to convert that DC into AC. We do not have a DC grid. Okay, in the the supply side, so we require to convert AC into DC and then supply it to grid. So you require, and also they don't they don't supply at the required amount of voltage. So you may require to have a DC-DC converter to boost voltage. Okay, so and then another important things which has become a popular is what you call the back-to-back converter topology. That is AC to DC, DC to AC kind of a topology which has become very popular. Okay, integrating. Okay, it has a DC link. It can completely separate out the two part of the network. Okay, so one is the AC side, another is the generation side. Another things which is coming up now is what you call, the cycloconverters has become obsolete because of the large commutation problem, because of the large number of switches. The same thing is coming up in a smaller lesser number of switch called as a matrix converter. Remember, when you try to convert, say, solar power from DC to DC, then DC to AC. Okay, when we are converting AC to DC, then DC to AC. Why can't you convert AC to AC directly? Okay, why can't you utilize the topology like a matrix converters to convert AC into AC directly? Avoid a conversion stage in between. Okay, this is more efficient. Okay, but it has its own issue. Okay, you don't have inherent separation. Okay, like a DC link, what you have in a back-to-back converters. Okay, so there are quite a number of topology. Of course, some of your participants can come up with your own topology for integrating wind and solar. There are a lot of opportunities. Okay, all you can improve the topology. You can come up with your own topology. It's all you can play with what you call IGBT switches. Okay, you can fire it in proper sequence and get whatever you want. You can design your own waveform with the power electronic switches. That is what is the flexibility in the power electronics. Okay, so then before going to issue, let us talk about what you call how we can integrate wind and solar systems. Okay, so as you know, if I talk about wind, earlier system they were using what you call induction generator. Current generation of wind systems are talking about utilizing the double fed induction generator in the larger scale and permanent magnet synchronous generator in the smaller scale. Of course, the double fed induction generator has become what you call important part of any kind of wind system. Okay, so there are different kind of possibility in double fed induction generator. As you know, you can, this is an example like what you have done in your popular experiment in case of the DC machine as a Kramer drive. Okay, so slip recovery scheme, same thing has come as an induction generator based what you call the wind interface. You can see the wind and operation with gear. Okay, and then the supplying through both to stator as well as rotor, and you can have power electronics in the rotor, okay, as well as in the stator also. But this has become the popular topology in the larger scale of wind turbine. We are talking about megawatt scale of the wind turbine current, the larger capacity. Okay, so and also of course the permanent magnet generator, as you know, compared to synchronous generator, permanent magnet generator do not require an excitation. Okay, they do use the permanent magnets. Okay, so they can be utilized for a, right now they are utilizing for a smaller plants, and the cost of the permanent magnet is very high. India is poor in permanent magnet resources. Okay, we are dependent upon the supplier from outside. Okay, so these are rare earth materials which are have an important place in a periodic table. Okay, so permanent magnet synchronous generator based systems also coming up for wind. You can see it is directly integrated to grid through power electronic interface, highly flexible to control. Okay, not like the double fed things, and index the permanent magnet are rugged in maintenance. Okay, so you can talk about, you can see a lot of implementation in future the wind system. Important thing is both require a power electronics. Of course, when I talk about power electronics, the control becomes a very important part of this kind of topology. Okay, so this is the kind of how do you interface wind and solar. We are all know, most of us know, some of you may be having in your house a grid tie inverter. As you know, it has become a popular now because the government can reduce, are getting your electrical bill reduced. The government is trying to reduce your the electricity bill if you are injecting what you call the solar power to the grid. Okay, so instead of becoming only a what you call the supply your load, you can also generate power and supply to the grid and earn money. Okay, so that is what is the future. You can set up your own rooftop solar power plants and interface with the grid tie inverters. Okay, of course, a popular solar topology is a DC-DC converter to boost voltage, and you have a DC link. It can be a battery-based link, and then you have a DC-AC inverter. This is what you call a grid side inverter. This is the photovoltaic side DC-DC converters. There are, of course, a different topology. You can see a lot of topologies are coming up. You can think of single phase implementation, three phase implementation. There are centralized grid tie inverters or distributed grid side inverters. Now the people are talking about having inverter back of the panel itself, micro inverters. Okay, so that is what the kind of solar panels technology we are talking about. A panel will be the backside of the panel, the inverter will be sit on the power electronic interface. Okay, no separate extra interface is required. Okay, that's what directly converting to AC and then PD to grid. Okay, so the micro inverters are coming up. Okay, instead of having what you call the centralized and other things. Okay, so and you can see the characteristics of the photovoltaic plant. Okay, where is with the what you call the open circuit voltage, the short circuit current variation. Okay, so that is how we can interface solar photovoltaic system. Okay, so we talk about ground implementation as well as rooftop implementation. Rooftop implementation has becoming popular. Another important, as I told you, these are not a renewable as such. They are all comes as a energy efficient source. We can talk about the micro turbine based system. You can see it looks like a refrigerator what you have in your house. Okay, so this is a single shaft design. It's exactly similar to a diesel generator. Some of you might be knowing experience with a diesel generator operation. Okay, but this has an efficiency above 60 to 70%, not like as that of a diesel generator which has a very low efficiency. And the pollution absolutely what you call nil. Okay, so ultra low emission from this kind of plant. Okay, modular kind of a system for generation of power, highly efficient. And the similarity, we require a power electronic interface because it generates at very high frequency. Permanent magnet synchronous generators are utilized here. And then what you talk about the fuel cell, it's also energy efficient source. Both of them, like if I talk about a photovolt, the micro turbine, okay, the cost of this turbine technology is around what you call the 20 to 30 lakh per kilowatt. Of course, at smaller scales, it's very difficult to have this kind of things. Okay, right now they have capstan micro turbine which are coming at 30 to 30 kilowatt, which can be operated at various level. Okay, there are different manufacturers. Micro turbines are also available, but they are very costly now. Per kilowatt kind of a system may cost you around 20 to 30 lakh. If you talk about solar, it is costing about 40 to 50,000 now. And if you talk about wind, it may be around 80 to 90,000 kind of a per kilowatt system. And if you talk about fuel cell, okay, it's also similar to that of micro turbine. Per kilowatt system, you may get at around 18 lakh. Okay, think right now these systems are very costly. Photovoltaic system is exactly similar to fuel cell system is exactly similar to photovoltaic system. Okay, whereas in a photovoltaic system you have photovoltaic effect, fuel cell you have chemical. Whereas in interface it's exactly similar with that of the solar system. Okay, so whereas a permanent magnet, the micro turbine system is similar to your wind system based on a permanent magnet synchronous generator. Remember, both require a power electronic interface. Okay, so that is what the importance of the power electronic technology in the current integration of the renewables as well as other kind of distributed generation sources. Okay, so you can see the fuel cell characteristics. Okay, so fuel cell, what you have in our laboratory, this is what we call the load module. This is inverter and things, power electronic interface. Okay, and then we have here the converters. Okay, DC-DC converter is there. Okay, there is a what you call fuel cell stack. Okay, this is the hydrogen supply. Okay, so that is how what you call you can. This is 1.2 kilowatt heliocentric permanent proton exchange membrane fuel cell system. What you had in our institute. Okay, some of the IITs now they have brought up this kind of system in even at the larger scale. Okay, so that is how you can have. Now, what is that challenge? Why it is become so complex to solar and wind system? Okay. So, as you know, we have now talked about the integration. Now we talk about the issues related to power, the smart grid. Conventional grid power flows from generation station to the load center. Okay, you can see there is nobody were allowed to connect any generation sources at the distribution level. No way chance of power flow back. But if you think of distribution system, the smart grid network will have a lot of renewables, fuel cell system, wind system, all those can come into picture. Okay, so and another important thing is going to happen is all your vehicles also will coming on the grid. Both they try to supply as well as consume power. Future is based on electrical vehicle and our entire transportation sector will come on your grid. Okay, so how do you manage that kind of a grid? Okay, so you know, as long as you manage it, so the generation and the supply, the what do you call the consumption, absolutely no issue. But here, anytime wind may go up, your load may be low. Like in the night time, midnight is the generally load will be low, and that is the time wind will pick up. How do you manage? What may happen when power goes up? The injected power goes up, the voltage goes up. Moment voltage goes up, you know Kirchhoff's the laws. Okay, so current start going reverse back. How do you manage that situation? Okay, so that is the problem. Okay, but in the convention there is no generation, so there is no possibility that going back. Our network is not designed to operate in the bidirectional power flow or active. Okay, so but you cannot replace entire network. You have to have your own technology to solve this kind of issue. Solutions you have to design. You have to overcome this challenge. All this create lot of problem. Sometimes what may happen, some of the feeder may get separated out. Okay, how do you manage the supply and the demand? As long as you manage supply and demand locally, there is no problem. You are not going to disturb the grid. But that is not going to happen. If you have a larger penetration, your voltage goes up. Some of the European networks have experienced this issue. You might have seen the research paper and other things. Whereas in Indian grid, we have a demand and supply mismatch, as well as our penetration level is around 20%. Issue is not that much. So that's why we are talking about more and more integrating renewables. If you talk about Germany, they are trying to what do you call it, look into situation where the renewable is more than the conventional. Okay, how do you manage this kind of bidirectional power flow? Your battery sitting in the vehicle act as a supplier as well as can discharge or charge from the grid. Okay, so this is what is going to do or creating lot of issues. Apart from that, you imagine maybe there are four photovoltaic system on your feeder. They may come on grid and disconnect, come on grid and disconnect. What do you experience? Or their output keep varying, what do you experience? Okay, all this. And as you know, we are all talking about the power electronic technology. The same power technology also pollute grid in terms of harmonics, in creating unbalance, creating lot of DC issues in the grid. Okay, same power electronic create problem in the operation of the grid. How do you take care? That is why the whole world is, if you talk about any whether it's a power system, power electronics, and other thing, all are working on a power electronic interface to define, to design your own control scheme to avoid the injection of injection of reduce injection of the harmonics and other things. Voltage waveform distortion is nothing but the harmonics. Okay, so the transient voltage variation, phase voltage imbalance, all these power quality issues. Okay, some of speakers may talk about these issues which are coming in the grid. Okay, same power electronics is causing this problem, but power electronics has more plus flexibility in control. Okay, very good. Become a technology, efficient technology for interfacing. So we need to continue. At the same time, you need to have to solve those issues, reduce the harmonics. Okay, another important thing, as I told you, some of the network have already experienced that whenever the demand low, the voltage goes up because of the renewables. Okay, so inject also, if you inject lot of power to the grid, because you know renewable power input is, there is no need to pay for anything. Why can't you make it to generate less? You generate as much as possible and use it and store it. But we do not have that kind of mechanism. So voltage goes up, and that is where the problem our requirement is to maintain within plus or minus. If it goes above, then we cannot imagine the situation. Okay, so islanding may happen. Okay, so separation of the network. Islanding means separation of the network. We'll go into issue. We'll see that this is the problem. Then, as you know, conventional grid do not have, were not designed to have what you call the generator of the distribution network. But now, generators are sitting on the distribution network and supplying the fault current. Network may experience that even there is a fault, the substation end may not see the fault because somebody else supply the fault current. Okay, stability, of course, Indian grid, we do not have that much problem right now because penetration level is less. But if you think about some of the European network, they are experiencing situation. Apart from that, there are several another important thing which is coming on the bigger issue is the protection. As you know, the protection becomes a very important thing. As you know, these generation sources will influence the protection level settings like circuit breaker settings, create mal operation in the circuit breaker, or sometimes they may not operate. Okay, and as you know, our network is highly coordinated in terms of protection. If something fails at one end, it leads to catastrophic effect. Okay, and another important thing is the future is going to be a DC. You will have in home level DC, grid level AC. So it is a AC DC kind of a thing, hybrid grid. But as you know, DC do not have natural zero. Okay, that creates a problem in circuit breaker and other operation. Okay, and designing circuit breaker becomes a very important task. Okay, so there are a lot of issues related to protection. Your entire relay system will not coordinate properly. Okay, because of the generation coming on the feeder. Okay, so these are all going to be issues. What we talk about as a research tomorrow, you will see on the practically that this kind of a things becoming more and more visible in our grid. Okay, as you know, just if you talk about that, these are issues and list issues, you may not appreciate what you call the importance of it. Yes, we will have to do with simulation, you have to do with prototype development, you have to do with a practical investigation. That yes, these are very issues of what you call the smart grid operation. I just want to demonstrate to you that there exists a problem of voltage rise in our distribution network. Okay, so imagine this is the one practical feeder system, okay, which is for fibers network, a very simple fibers network. You are familiar with the load flow analysis where you do calculate the load, the voltage at each buses and other things. Okay, so you see, and also we assume the loads are dumped, but loads may not be dumped at one particular things. It may be entirely distributed kind of a thing. Okay, so imagine there is no generation connected on this feeder. What you expect is, as you at the generating station, suppose you may imagine it's 11 kV feeder. Okay, the operator sitting at the substation level has to see that voltage is maintained constant throughout the network. But it is not going to happen because of the physical parameter of the network. Voltage keep dropping. Not only this thing, that is depends upon several parameters, several factors. Okay, so the last customer may not see the voltage level. His light may light up come to full bright only maybe in the night. Okay, so that's why I'm talking about long rural feeder. Still that kind of issues are there. So voltages keep dropping from the substation and to the customer. Okay, so that depends upon several parameters, several things. So when there is no generation, you can see voltage keeps dropping. Another important thing is, because voltage goes low at the last customer, what operator does is why can't you keep voltage a little bit higher here so that this person gets the proper voltage value? He knows that it will drop, and to compensate that drop, keep the voltage at this point higher, but within the limit. Okay, so that is what you see. It is not 11 kV, it is higher than that. Okay, so he will keep it rise its voltage level and keep dropping. If it is lower, if it is 1, you can imagine the voltage at the last customer. Okay, so that is without generation. Now try to connect one DG which is of 20 megawatt. Okay, imagine that this is maybe a wind or solar or what kind of whatever may be the DG. Okay, we are talking about steady state analysis. Okay, so imagine that and run your load flow. You will see that the voltage goes up to very high value above the limit. You see here and you see here above the limit at 4th bus. Okay, that's where you connect it. And it violates the limit. So what operator does is shut down supply because voltage is going up. He is not able to keep voltage constant. It is otherwise, if he is not, then he has to pay compensation because load may get damaged. Now another important things we'll see, you connect this generator at the 3rd bus. You can see still there is exist a voltage rise problem. Okay, in the 3rd bus. Okay, it is above the limit. Okay, so the voltage is going up still. But what you observe, effect here and effect here are lesser. Here it is less. So what observation you can do, as the DG connection point goes near to substation and the voltage rise effect becomes lesser. Of course, it depends upon several things. It becomes lesser. That is an important observation you have to make. Okay, so that is one of the important thing you need to observe. Okay, another thing, so what if there is a voltage rise, what people will talk, you reduce the capacity of a DG. Do you see that? Is it a good viable option when wind is blowing? Why to reduce the output? Why can't you utilize that? Okay, so that is where what you call as constraining generation. That is a simple solution. But is it a viable solution? Some of the networks in Tamil Nadu and other things, they were forced to do this kind of things. But that is not a viable solution. You have, when wind is blowing, utilize it properly, get supplied to the network. Okay, so you cannot have this kind of inefficient solution. So why you are not going to solve this kind of issues? Another important thing is connection point voltage becomes maximum as you go from substation, go from the last customer to substation, and voltage rise effect less. Of course, it get influenced by multiple DG also. Okay, so that is what you can see. Really, there is an issue, voltage rise issue. This is an important issue in a smart grid. Okay, so apart from that, there are several things also. If there is an issue, how do you control? Okay, so you have what you call the various methods control the active and reactive power of DG. Use the STATCOM, compensators, SVR, many things. Use load variation. Okay, of course, the variation in the R and X of the things are not possible because it is not a feasible solution. You cannot keep on replacing the conductor. Okay, and also vary the substation and voltage using the tap changing transformer. Of course, these are all conventional. Some of you can come up with issues. You can use the hybrid methods. Now, if you see many papers, research papers coming up with the hybrid method, combining these methods to control voltage. If you take more and more generation, if you talk about more and more generation, more and more rise effect will be there. Okay, so this is how you can solve this voltage rise problem. Of course, a lot of research is required. Okay, and another important thing is an islanding. As you know, when DGs are connected in a particular feeder, suddenly fault happens somewhere else. The circuit breaker sees the fault and may separate out. Once it's separated, DG is still it's in operation. It tries to feed the load. Okay. If the load and generation are not matching, of course it will not. Momentarily it will happen, this kind of situation. The frequency, voltage get excurted and everything get damaged in the connected part. Now, you have a DG, when power goes, why to shut down a power for this part of network? For your own maintenance and other work. Make sure that DG continues to supply with matching demand and supply. Try to provide. Okay. So how to make that things to happen? Remember, it is more problem with the power electronic based DG systems. Okay, future renewable sources, more of power electronics only, interface with the power electronics. So islanding occurs when a portion of the distribution system becomes electrically isolated from the remaining part of the power system, yet continues to be energized by the distributed generators connected to the isolated subsystem. Okay, so you need to continuously energize the load. That is more beneficial. That separation and energizing with the DG and operating it safely and secured way is called an islanding operation. Okay, islanding has a lot of issues. Okay, some of you can take into account how do you solve those issues. Okay, so islanding becomes very important in your house also. Sometimes network may get separated out. If you have a photovoltaic system, why can't you feed your own things? Okay, we are doing now with your inverters. Okay, but these are all possible with matching of the load and generation. So what are those issues in an islanding? Islanding issue is to maintain the voltage and the frequency. Reclosure, see, suddenly something may get reclosed, then it will be a problem for the people working on the things. And balancing a power generation supply becomes very important, because suddenly situation will happen. Who will match? Who knows how many loads? What is the amount of generation capacity? How do you adjust all those things? And another things, when grid is there, you have a neutral reference. When grid goes, who is responsible? Okay, so all this becomes a very important issues in what you call the islanding. And the nature of the signal, you can see suddenly islanding happens, voltage keeps decreasing. If you not done some attempt, voltage further goes down and your entire things becomes affected. Okay, and also it is also same thing with respect to the frequency. You can see frequency here is the voltage here. You need to operate the system at proper voltage level and the frequency. Okay, so that is what is a very important thing in case of the islanding. Okay, so you know there are benefits for islanding operation, operating in islanding, because you can earn a lot of amounts. Okay, the customers, okay, so get benefited, because when there is no supply from a grid device, the DG is supplying, DG owner, utility can earn. And IEEE recent standard, of course this standard is earlier one, now IEEE has come up with the improved version of this IEEE 1547 2018 standard, which says all your grid tie inverter must have the islanding detection capability. They should be able to operate your grid in islanding mode. Okay, so right now all grid tie inverter do not operate in islanding mode. Somebody may ask you question. You may have a photovoltaic system. Okay, when power goes, why can't you operate that? That is because of this, because of the security concern, and you are not allowed. But future, as per the standard, or you require to operate. In order to do that, your inverter must have capability. Okay, so grid inverter capability should be there. Islanding may be intentional or unintentional. Okay, islanding, to make it successful islanding, you should detect it, you should reclose it, and it should happen without notice of the customer. It is in a seamless way, it should happen. Okay, it should happen in a seamless way the islanding should happen. Islanding operation should happen. Okay. You can see the result here. Okay. So when the islanding happens, you can see the nature of the variation just we saw. And whatever may be happening, this thing should be able to maintain the voltage in a successful islanding operation. You can see here, grid connected mode, variational load, islanding happens, grid gets separated, again connecting it back, reclosure. Of course, reclosure is nothing but a resynchronization, synchronizing your islanded portion to the grid. Okay, so you can see this becomes a very important. What is the technique available? Some of my students worked on a lot of techniques on islanding. Okay, you can see our papers related to islanding detection. Okay, once you detect islanding, power electronics becomes a very important critical things here, because power electronic converter do not have capability to operate in islanding mode. You have to have design your own control scheme for operating them in islanding mode. Okay, so you should have what you call control capability. It becomes very important. Those who want to do research, they can look into that issue. Okay, and then as you know, I think there may be a lot of people may talk about power electronics. I will not go into detail. Okay, as you know, all renewable energy sources storage device require a power electronics. Wherever a power electronics converters are there, possibility of injecting harmonics, and wherever wind system and other things are there, there is a possibility of voltage flickers. Okay, so this is one of the practical result of voltage variation. Okay, because of the wind system taken into a particular practical site. Okay, you can see it create a voltage variation which will create a problem in operation of the devices. Okay, so you can see more of these things in, especially on an incandescent light, where you can see easily observe this kind of variation effect. This power electronics, okay, should the wind turbines and other things are creating this issue. Okay, so you should be able to control it, and the harmonics is another important thing. Okay, so as per the IEEE standard, you should be able to maintain the harmonics within plus or minus 5%. Okay, as in isolated it may be plus or minus 8 to 10%. But maintaining harmonics, imagine 10 generators with power electronics, they inject lot of harmonics at the grid level, the harmonics level may go up. So reduce the harmonics level. Okay, so there are a lot of things you can think of. Okay, you can think of doing a lot of research, how to do control harmonics and other thing, regulate, avoid a particular harmonics. Apart from that, we will have a lot of other things. Voltage sag, swell is there, sag is there, then transients, all this creates problem. Okay, so all this creates problem in operation of things. And as you know, if you have a problem, there are solutions also. Okay, you might be knowing, I will not think this one. DG is both problem as well as solution. Okay, that's because most of DGs have power electronics. Okay, there are a lot of solutions are also available. Another important issue is what you call the protection issue. Protection issue, as I told you, I have already talked about the issue. When you have a generation sources, they will try to feed the fault current from this feed. The fault current at the circuit breaker level will not exceed its limit. Okay, so when it is not exceed, it will not operate. Even there is a fault, system is not seeing the fault, it's not operating. What is that happening is a blinding. Okay, of course, each inverter can inject this much power this much fault current, and synchronous generator, you know, induction generator, you know, these are the amount of fault current they may inject during fault situation. Okay, so you are DG is unnecessarily blinding your protection system. And also sometimes one DG connected on another feeder, one feeder may feed the fault in another feeder. But if the fault current is higher, the healthy feeder also gets separated out. Okay, so that is called a false stripping. So there are a lot of issues. Of course, apart from this, as you know, our protection system is highly coordinated one, zonal protection and other things. Once failure happens in one side, will have a catastrophic effect. Everything may get failed. Okay, so that is where the problem is. Of course, this is becomes further things with the introduction of a DC. Okay, so protection issue becomes very important. So when you design a power electronics and other things, you should take into account of all these things. Okay, so that's what is the another important issue. Okay, apart from this, there are several other issues. Okay, the stability issue right now, Indian grid, we are not able to see that. Some of the European grid have seen. Apart from stability, there are other issues like DC injections. Okay, so and then the variation in the what you call the protection settings. Okay, there are many things, loss variation. Okay, so there are many other issues. I will not touch all those issues. Okay, so then if there is an issue, what can be done? How do you operate? So there is one way the concept has come up. Okay, of course, this is almost 10 years things. Okay, people are doing a lot of work with this concept called a microgrid. Imagine in your house, okay, you have what you call a battery system, you have vehicle, you have generation sources, all are connected together in a house and connected to a grid. Okay, so house becomes a microgrid. You have a load, you have generation sources, and you have also grid tie inverters and other thing if you have photovoltaic system. And vehicle is there, it has its own charging and discharging control. Okay, all this connected becomes a microgrid. House is also going to become a microgrid if you try to integrate more renewable. You have already inverters, everything. Okay, apart from that house, you have a lot of loads, DC loads, AC loads, all kind of things are there. Future, you can think of all your refrigerator, everything comes on DC. Indian Bureau of Indian Standard also coming up with what you call the DC grid things, the voltage level, everything. And in a larger scale, you may have a many number of generation storage source on a feeder or a substation level. It can become a grid. So microgrid concept assumes a cluster of loads and micro generation sources together with the storage devices operating as a single controllable module of distributed system and capable of operating both in grid connected and isolated modes of operation. You can see in a larger perspective. Not only photovoltaic wind system will come into picture, your PV fuel cell will come into picture, micro turbine come into picture, all are operating, all having a different characteristics. How do you operate? Okay, so think of several houses, several microgrid connected in a main grid. Okay, and this is the kind of a situation comes up. Of course, by doing so, there are a lot of issues you can solve, and also there are a lot of things also come into picture, becomes a challenge for you. Okay, so then how do you control this? Becomes a very important thing. Okay, how do you control the microgrid? If you have a solution, this is a kind of a design solution where you try to integrate renewables in a form of a microgrid rather than a single integration. You control in that way. Okay, so you control all this together so that there won't be any voltage and the frequency variation. Okay, so that is how the future is. Okay, so you require a control scheme. Okay, another important thing, as you know, house, in case of your house, you have mobiles, you have computer things, you have fan, you have refrigerator, you have what you call air conditioner, all there. Some of them are DC load, some of them are AC load. DC load, what you are happening, you are receiving AC grid from the AC grid, converting into DC and supplying it. You have a loss. Your photovoltaic system generated DC, why can't you directly connect that into DC? And for your AC and your refrigerator, you use a DC AC. But future, this refrigerator, air conditioner will also become a DC. Okay, and your water pumping system also become a DC more things. Okay, so future will have mixture of this. So whatever DC you require, DC supply DC and convert that into AC, extra power supply to grid. You cannot replace the grid, AC grid suddenly. The future is both AC and what you call the AC microgrid and DC microgrid together become a hybrid grid. Okay, so that is what is going to happen. Okay, so you need to, how do you control? You have AC grid one side, DC grid, all those things. Okay, so these are the loads. You can see there is a lot of what you call the load things. Okay, so there are load various different kind of DC loads are coming up. Okay, as you know, the lighting industry, okay, everything is CFL and your incandescent lamp get replaced with LED now. Incandescent to CFL, CFL to LED now. LEDs requires a DC. Okay, so you are using your lighting has been going to the LED. It is all your house also getting LED now. Motors also going to be BLDC and other kind of motors. And then electronics already is working on a DC. Then why can't you DC? Use a DC. Okay, so there are what you call advantage of a DC system, that no concept of reactive power in a DC system, no possibility requirement of synchronization, no what you call the different frequency, reduced losses also there, control becomes simple. Okay, but protection issue is there. What voltage level we have to operate? DC. So DC, there are a lot of problem with the protection. Whereas in AC, you need to synchronize, you need to match your induction motor draw inrush current, huge amount of current. Your induction motor, this thing can create an imbalance in situation. All this problem. The present trend is to mix of this. Both household level you use DC, grid level let it be in AC. Mixture of AC and DC is the things. Okay. So then how do you control? Control becomes very important. Hello, Ganesh? Ganesh? Ganesh?
Yes, sir. Yes. Yes,
yeah,
sir.
I will take another 10 minutes.
Yeah, okay, sir. Okay.
Complete presentation. I will share some of my this thing. And then we can have some question things you might have got
Yes,
in the
sir.
box or something.
Yeah. We go on the WhatsApp group also, sir.
Okay. So what we'll do is first let me complete another 10 minutes. Then we'll ask me the question.
Yeah,
okay.
Yes, sir.
You can read out the question and I will answer.
Yes, sir. Yes, sir.
Okay. So let me continue. I may take another 10 minutes. Okay.
Yes, sir. Yes, sir.
So power, the power electronics control becomes a very important role, because in a microgrid your loads are LED drivers are there. Motor requires its own control. Photovoltaic system has its own power electronic interface. Your battery system, which is used in a vehicle, it has its own.
सर आपके पास है ऑलरेडी है ना शेयर
Hierarchical control scheme is coming up as the answer. Okay, so at your household and demand.
आप नहीं है
And then
एक्चुअली खुद का एक्चुअली मेरा अभी तक अपडेट नहीं करके दिया है मेरा सब्जेक्ट का
control. You can have a data.
मैं दे दिया पूरा मैडम को
Hello, there are some noises are coming up. What noises are coming up?
Hello, sir. Just a minute. Get hang.
You can ask them to unmute.
Yeah, the system is get hang.
Hello, tell me. Hello, Ganesh, tell me.
Sir, system is get hang. Just a minute, sir. Just a minute.
Okay.
Just a minute.
आप अनम्यूट नहीं किया मैडम.
Hello, sir. Just a minute.
Hello, tell me. Can I?
Sir, just a minute. Somebody has opened their mic and we are unable to mute him. Just a minute. Hello, sir. You can
Can I continue?
Yeah, continue.
Okay, so there are what you call the hierarchical control things are coming up as an answer to microgrid control. Okay, so control at the household level to balance the load and demand. So you can able to control, you can try to match load and demand, then you will get what you call a primary control. Primary control primarily means is controlling the injected active and reactive power. By doing so, by controlling active and reactive power, you will be able to control the voltage and the frequency. Okay, so at primary level, you try to exercise that. So match the demand and supply. And as you know, this is the fastest possible. As you know, there are several houses will be there, or there will be several layout or buildings or apartments. Each act has its own microgrid. Everywhere they try to control this. This may create further problem in the later part. Okay, in the larger or the substation level. There they will have what you call secondary control. Further adjust the frequency and voltage. Okay, so as you know, there may be several substations in a grid. Each substation they will try to adjust voltage and frequency. That may create further problem later. Again, voltage and frequency variation may be there. That is generally controlled by tertiary control. Okay, so in the primary control, you try to adjust the active reactive power, voltage and the frequency. Secondary control, you try to again finer adjust. Tertiary again finer adjust. If you talk about the time scale, then this is the fastest, the primary control. This is the slowest, and then see this is the second this thing, and this is the slowest. Okay, so that is how the control, the timing response will take place. Okay, so then how do you do primary control? Because as you know, in case of the power electronic based DG systems, we have to have external control. Power electronic do not have its own inherent characteristics of controlling active and reactive power. Whereas a synchronous generator has its own inertia and it tries to by drooping it. Okay, by the natural droop things, it will be able to adjust the voltage and the frequency. Okay, which is not there in power electronics. You have to design. Okay, we'll look into the primary the control. Okay, so as you know, most cases grid tie inverters will have PQ control, voltage and the active and reactive power control using the what you call the PI controllers. You might be knowing different types of controllers. PI controllers are utilized to control the active power and reactive power based on certain references. Okay, most of the grid tie inverters available right now are using these control schemes. As you know, PI control this 2-loop or 1-loop PQ control scheme require what we call the spark transformation. You know what is spark transformation, which requires a theta which comes from a PLL. Okay, so PLL gives you the theta, okay, and which is used for a spark transformation, transformation and inverse transformation. Okay, so you will generate a control signal, and that will in turn generate a PWM signal which control the injected active and reactive power. Okay, so any grid tie inverter is require this control method control. And another things you need to know, as per the grid code, whenever inverter is in the grid connection mode, it should be able to control the active power. Okay, it is not controlling the voltage and the frequency, which is responsible for voltage is responsible for the grid, responsibility of the grid. Okay, whenever what you call the it is get islanded, you need to control voltage and frequency because grid will not be there. You have to adjust the voltage and frequency because you have to feed the loads with the constant voltage and the frequency. So power electronics interface require two separate control strategy. You need to switch over. Okay, so you can what you call think of voltage and the frequency, which has become standard. Now, if you see, imagine this with a single inverter. If you have a multiple inverter with a common load, who will tell them how to share? Whereas a synchronous generator, it has a natural droop characteristics, which is not there in case of power electronic interface. You have to introduce droop externally. You know the droop characteristic. You see frequency and voltage droop. You have to introduce a droop so that they share the loads. In the conventional grid, we assume the voltage is it is more of inductive rather than resistive, but it is not so in case of the distribution network. Okay, if you assume a conventional grid, you can control the frequency by controlling the active power droop. You can control voltage by controlling the reactive power droop. Okay, and but that is in case of the transmission network, which is a more inductive, whereas a distribution is more of resistive. Exactly reverse will hold a relation. By controlling the active power, you control the voltage. By controlling the reactive power, you control the frequency. That is how it will operate. Okay, so that is how it will operate in the what you call by introducing the droop. You have already know the droop characteristics. So this is what is the primary control. Okay, so this you can see the PQ control is modified with the droop coefficient. KP and KQ are the active and reactive power droop coefficients. Apart from this, as you know, our network, we assume inductive or resistive, but it is not going to be constant. It will keep varying. How do you take care of the effect of variation in the network parameter? It may become inductive, it may become resistive. So they brought a virtual impedance concept. With the droop, virtual impedance concept is implemented. That's what is the thing. So this shows you a simple PQ control scheme implemented in MATLAB. PI controller. Okay, you can see VDC control at the outer loop, inner loop. You control the active power ID with respect to reference and IQ. You may treat it as 0 in future grid tie inverters. This controllability is enabled by the IEEE standard. PLL gives you the theta. Okay. So if you talk about microgrid implementation, some of my students have done micro implementation. You can see one paper. Okay. So you can see this paper. To start microgrid, we try to implement in simulation. You can see this microgrid consists of the grid, use SOFC fuel cell, then PMSG, okay, wind-based system, ultra capacitor. You have no ultra capacity characteristics, it can give a burst amount of energy. Then you have battery, then you have what you call DC loads at a different voltage level, then you have electrolyzer which generate the thing which generate what you call the hydrogen electrolyzer. Okay, all these are there in this microgrid, which is implemented by one of my PhD students. Able to study these are the parameter, and This is another combination of the same. Okay, we try to implement. Okay, and if you see the result, you see the wind variation, what you call the dump load variation. Wind system require dump load, waste the power, because we are not predicting wind exactly is difficult. Total power generation compensated by fuel cell. Okay, you can see the power variation. Okay, so how the total required is supplied by the various sources, so you are able to operate them coordinated way. Okay, all this you can see the ultra capacitor power, battery, all these things are there. Okay, so and also if you see the DC link voltage variation, you can see there are variation. Of course, this variation should be minimized. Okay, so you are able to keep constant the DC link voltage. That's one of the challenge. And then in islanding mode, in a microgrid operation, grid connected mode is not much challenging. Islanding is more challenging than the grid connected mode. Okay, so you can see, because the DG is responsible to control voltage and frequency, you can see how things are compensated. Okay, with various sources and storage devices. Okay, here also you can see with various storage, different scenario you can see. Okay, this is another scenario. Okay, wind variation. Of course, there are so many variation. You can go through that paper. Electrolyzer. Okay, as you know, electrolyzer produces hydrogen from water. Electrolysis process. This is a fuel for your SOFC fuel cell. We were trying to connect this electrolyzer output to SOFC, but there was some pressure problem. Okay, so what you call the wind is also there. We consider wind step variation. Okay, so there is this also quite few results, of course, because of the time things I will have to rush. What we have done is, instead of saying once we have done a simulation, why can't you implement in a real time experimentally and verify? We try to implement using an experimental tool. As you know, nobody allow you to in power system to directly touch the power system and operate, do the experiment. Okay, we try to do with what you call a Typhoon Hill hardware in loop simulation. One of my PhD student implemented it. Okay, so 2 DG based system. Okay, so hardware in loop kind of a things, and with the load. Okay, and then the control schemes. This is the Typhoon Hill control things. Okay, so this is the implementation what we have done. Okay, so you know the Opal RT is similar to Opal RT. Okay, Typhoon Hill is what you call one of the important real-time tool which helps like where you get almost a practical kind of a results. Okay, so we try to implement these things in our institute. Okay, so we develop the control schemes. Okay, with a Droop, you can see the Droop control schemes. Okay, we try to implement that. Okay, PLL for a grid connected, this is for isolated case. Okay, Droop comes into picture in isolated mode. Okay, so we implemented voltage and the frequency Droop. This is a control schemes, and this is an islanding scheme. So we implemented same theta reference which we use. What you call the PLL can also be implemented to identify islanding, because theta variation will be very small when it is in a grid. When it is an island happens, it goes increasing. We can have a threshold value and then we can separate out. Okay, so then the same thing, you have to match the voltage and frequency and the angle to connect it back to the grid. So we studied in a grid connected mode. You can see the grid connected mode result. Okay, with the Typhoon Hill software. Okay, so voltage and things become is constant. Okay, variation in the load also. Okay, so you can see the reactive power variation here, active power variation. They are able to supply the required amount of load to DG systems. Okay, so you can see the microgrid operation. Okay, so reactive power variation, of course we have a reactive power, this thing very low thing. Okay, so you can see the reactive power variation supplied to the load. And then what you call the another important, as I told you, standalone mode. Okay, so we try to separate out, study in this islanding mode only. You can see the how load variation, we are able to keep the voltage and the frequency constant. In this case, this is a theta variation in. Okay, so that is how we did. Okay, so then the active and reactive power variation you can see, and then the actual technique where we try to have a seamless grid connected, islanded, grid connected. Okay, so you can see the islanding implementation here. The theta variation goes up, separate from the grid, operate in islanding mode, and connect it back to the grid. Okay, so that is how we could able to operate them in a seamless way. Okay, with droop control schemes we have implemented in our one of my PhD student implemented this. Okay, in the Typhoon Hill we have developed our own control scheme and PLL schemes. Okay, so you can see active power variation and reactive power variation. Okay, you can see the variation in the active power. We could able to meet the load requirement. This is the load requirement. This is generation and the various generation sources. Okay, both in grid connected as well as isolated mode. Okay, so this is the another again reactive the variation. Okay, so at the end what I can say is DG is very important things. Our smart grid with DG is becoming more and more complicated. DG penetration can help you to come out of your climate change and other problem. Okay, and also the DG going to play a very important role. Lot of research things can be done to overcome the issue. I have already thrown a light on the issues. You can implement them and provide a solution. Okay, there are a lot of papers are coming up. If you ask any university now, people are doing, those who are doing PhD and other things, they are doing research on the DG, mainly on the issues, topology, control schemes and other things. Okay, so you can, some of you can take these things and what you call come up with your own solutions. Okay, thank you very much. Thank you for inviting me to share my some of my thoughts. Thank you to the Ganesh as well as thank you to the department for inviting me there.
Thank you, sir.
It's a good experience for me. Thank you.
Yes, sir. Thank you. We also have a good experience with you.
So Ganesh, you can
Yeah,
you can what do you call the read out the questions and I can answer.
Yes, sir. Yes, sir. We are asking.
So the first question is
Tell me.
electrical vehicle charging problematic for power system or microgrid, especially considering peak hours?
Which cars?
Peak hours.
Peak hours, yeah. Yeah, when I talk about a vehicle, as you know, the vehicle required a charging and discharging. This charging, as you know, we are now what you call accustomed with what you call the petrol bunks. You go and they will put up the petrol immediately, okay, and you pay money and come back. But in charging and discharging, it is not so. It may require its own time, and what people are coming up with the fast charging things, but this fast charging lot of it create lot of disturbance on the grid. Okay, so this charging and discharging event create disturbance on the grid. Okay, so that is where what you call you need to, and also another thing is it may create unbalance in the system also if it is fed by the photovoltaic system or something. Okay, so balancing a grid also becomes very important. One of my PhD student also is doing on that things. We try to balance what you call the grid. Okay, so that is the issue, and this fast charging and slow charge, this charging create lot of problems. Okay, bring the what you call the lot of issues on the grid. Okay, so apart from that, DG also has its own issue if you talk about photovoltaic and other things. Okay, so actually the peak hours, as you know, the peak during the daytime, the around afternoon things. Okay, so there will be a lot of problem it may create if you have right now, there is no problem because we don't have much that kind of what you call the charging stations. Only very few charging stations are coming up. Whereas if you talk about like our petrol bank, now if you replace all this petrol bank, they become a charging station. It creates a lot of issues in the operation. So people are doing a lot of things now. Okay, so there are certain standards and other things are also coming up. Okay, so
Yes,
hope
sir.
I
Thank you.
answered the question.
Yes, sir. Thank you. So one more question from my side.
Tell
Okay.
me.
So some of our colleague has experienced this, that they have installed a solar PV at the petrol pump. Okay.
Okay.
And when the petrol pump is get connected with the grid, there is no problem of the reference frequency. But when the electricity is gone, as the reference frequency is not available, that inverter was not going to work continuously. So to track the frequency under off-grid mode, that is the main issue. How to give the reference frequency in the inverter, because nowadays in India, whatever the inverter are coming, that are not able, we are not able to set the frequency in that. So how can we work on that?
Yeah, this is a very important thing. Of course, a very important research issue. Okay, so it's very this thing opt question. As you know, when you're supplying your charging station with a photovoltaic system, okay, when there is no grid, when there is a grid will supply the frequency reference. When there is no grid, who will supply the frequency reference? And of course, this reference is a constant. Okay, if you talk about a control schemes in isolated mode, okay, you can give a constant frequency reference. Okay, then how do you generate, how do you get that constant frequency reference? Okay, so that is where you need to, if you try to implement through PLL based things, you can have what you call a constant frequency there, frequency value. There is no disturbance on the frequency, because when it is what you call isolated, the grid is not coming into picture. Okay, the frequency has to be a constant. So you can control that by properly having a droop concept there. Okay, so you can control the frequency is related to active power variation in case of the resistive grid, in the case of inductive grid, and reactive power is depends upon the what you call the voltage variation. So by controlling the active and reactive power output of your photovoltaic things, you can able to control the what you call the required supply voltage and the frequency. But doing so, you require to have a drooping concept. Okay, so the drooping concept required to implement if you have multiple sources feeding the what you call the loads. Okay, so you need to try to develop what you call the droop control concept in that. Okay, and also the reference frequency things you need to what you call by doing controlling these things within the inverter, this one you should able to maintain the voltage and the frequency. Okay, so
Okay,
people
sir. Thank you.
group control schemes for that.
Yes, sir. Yes.
Hope I have answered that question.
Yes, sir. Yes, sir. Thank you.
So the next question is, how can system heal itself automatically if due to some problem a fault occurs, let's say some component are damaged, without changing them, how can a system come back to its normal operation?
Yes, it is a opt question. When there is a fault, okay, so like, see, sometimes the faults of what you call the intermittent nature. Okay, so like you might have heard about auto reclosure. Just an example to self-heal system. What distribution companies they are doing is they are replacing the present manual reclosure by auto reclosure. How auto reclosure works? Okay, so once the system becomes healthy, automatically there is no manual intervention, itself will connect it back to the grid. But to make system healthy, okay, sometimes manual intervention may be required, like when the component is damaged, until unless you replace the component damaged component, You cannot. But who will tell that the system has become healthy? You no need to go physically and close that switch. Once your system is repaired, automatically it will detect and it will connect it back. This is what the self-healing feature, what I am talking about. When system is healthy, you no need to go there, or you no need to have manual intervention. Itself will connect it back. But when there is a physical damage of a component, another thing, you have to replace that. Okay, so when I talk about self-healing, you can think of the first level of implementation is auto reclosure. Okay, so that is what we require, and also it will correctly indicate where exactly fault. Okay, you might have intelligent in the system to indicate where exactly fault, and you directly go and do that job. Once system becomes healthy, automatically everywhere it is get connected. You no need to go and connect it. Right now people are doing manually. You might have known, if you ask any substation operator, he will say what they will do, what is the sequence of event if there is a fault happens. Okay, so that is how what I am talking about. Some of you have to identify the fault. Then once the fault is identified, control signal should be given to the people to rectify if there is a damage. If there is no damage, it will wait, or it will automatically rectify itself. Okay, and then what you call, then then measure the system healthy condition and come back to the normal mode. That is what is called as self-healing. Okay, of course, if there is a damage in the component, nobody can help. You have to replace manually. Okay, is there any other question?
Sir, the last question.
Tell me.
Does still reactive power management find lot of scope for research in microgrid?
Definitely, definitely. This, as I told you, the current PV grid inverter going to become a multifunctional inverter. People are now concentrating on a lot of research on multifunctional inverter. One of the important function is to reactive power control. Right now, grid code says that grid inverter should not control the reactive power, only active power. But the IEEE 2018 standard, it has been revised that the reactive control capability also you have to utilize. Inverter has that capability. Why can't you utilize? Okay, so they have come up with to utilize that also. Now you don't need any other things. You can manipulate. You can what you call control this utilize this reactive power control ability to control or manage the reactive power in the network. You may observe or you may supply, but of course your inverter rating, everything may goes up, cost may be a little bit higher, but there is a possibility. And this is going to be a very important topic for research. Okay, the people are talking about multifunctional inverter, single inverter doing multiple job. Okay, so there is a lot of possibility utilizing this for reactive power management, and it is going to be a very important issue in a microgrid. Okay, so is there any other question?
No, sir. Thank you,
okay,
sir.
Thank you very much.
I would like to thank today's speaker, Dr. Gaonkar sir, for this resourceful session. I'm sure participants have found it very interesting. Now I request Jadhav sir to please give the instructions.
Thank you, sir, for being
Thank you very much. Thank you very much for your invitation.
Yes, sir.
Thank you for the team which is organizing this workshop. I think a lot of other speakers also going to deliver a lot of lecture.
Yes, sir. Yes, sir. Yes, sir.
I have thrown some of light. Thank you very much. Can I leave the meeting now?
Yes, sir. Yes, sir.
Okay,
there is request to the participant that tomorrow is the holiday due to the Ananta Chaturdashi, Ganesh Visarjan. So tomorrow there will not be session, but on the 2nd of September, you have to join sharp at 9:45. Sharp at 9:45. We will soon share you the Google Classroom link and other details on the WhatsApp group. Those who are not on the WhatsApp group, please drop me the message. Me or Boa sir, drop me the message. We will include in the WhatsApp group. Okay. Already you have received the link in the WhatsApp group, link of the WhatsApp group. You can join from there. Thank you for being a day with us. Hope you enjoyed the today's session. Good evening. Okay, so thank you.